Dear participants of the conference, I'm Nataliia Kuzmina from the Dragomanov National Pedagogical University. Let me introduce also Petro Samusenko, National Technical University of Ukraine, and Anatolii Kuzmin, Tarashevchenko National University of Kiev, about some aspects of the organization of students' individual work at pedagogical universities in the process of teaching classical optimization methods. We analyze the specificities of organizing the individual work of students who study according to the dual educational system by using new approaches in the educational process, such as elements of flipped learning and the using of the modern information technologies. The main purpose of introducing a dual educational system at a pedagogical university is to create conditions and opportunities for the most prepared and motivated students to effectively combine theoretical training at the university with the practical implementation of their knowledge at school. These are students of computer science specialties who were the participants in the pilot project of implementation of the dual system of education at our university. They learned respective disciplines according to individual plans and schedules. One of the effective ways of organizing students' individual work is the technology of flipped learning through various e-learning courses, for example, the distance learning system Moodle. The using of flipped learning technology provides an opportunity to make the transition from the teacher as the main source of knowledge to practice-oriented learning of students and their active involvement in the educational process. Unfortunately, it should be noted that the interest of modern young people in the classical theoretical study of mathematical disciplines has decreased. Most of students use, if it necessary, the internet reference resources or the most simplified methodological developments. Therefore, to provide students with the basic theoretical knowledge, it's necessary to use new approaches in the educational process with modern information technology. In particular, computer math systems are advisable to use not only while performing the practical tasks, but also during teaching the basic theoretical mathematical foundations, avoiding at the same time incorrect simplifications. Some aspects of teaching classical optimization methods in the course of mathematical programming to students of computer science specialties are presented in our article. The subject of studying this course is the basic information about the problems of mathematical programming, classical optimization methods of functions of one or many variables, the basic formulations review, methods of researching and solving problems of linear, nonlinear, integer, discrete, stochastic, convex, dynamic programming, and also modern information systems and technologies that are used in researching and solving the specific applied problems of mathematical programming. To effectively organize the individual work during their studies, students should develop, implement, and protect their individual or group projects. Here is an example of tasks of the individual project during teaching the mathematical programming. Task 1. Formalize, build mathematical models, solve the ancient extreme problems such as Euclid, Nataliia, Kepler, Steiner, Heron, Apollonius as nonlinear programming problems. Solve the selected nonlinear programming problems by Lagrange multiplier methods. Then by a classical method of finding of extremums of functions of one on many variables. Then by approximate gradient methods. Then by using the genetic algorithm. The last task, compare and analyze the results. Further, we demonstrate some elements of performing such tasks in the environment of Maple computer math system for Kepler and Steiner as ancient extreme problems as conditional and unconditional optimization problems, respectively. You can see the geometric visualization and mathematical models of Kepler and Steiner problems. Kepler problem. Fit the largest volume cylinder into a sphere of a given radius r, two-dimensional model and one-dimensional model. Steiner problem. In the triangle plane, find a point the sum of the distance from which to the triangle vertices is minimal. Its model. Numerical solution of the Kepler problem for a sphere of the given radius with using the extrema function is presented here. The answer coincides with Kepler's analytical solution of the problem with sufficient accuracy. On the next slide, Kepler problem solution by using a package optimization is shown. The results coincide with above. Further numerical solution of the Steiner problem as unconditional optimization problem by using the minimize function is presented. The Lagrange multiplier method, the main idea of which is to transform the conditional optimization problem into the unconditional optimization problem, is implemented in many optimization software packages. Further, we demonstrate the Lagrange multiplier method application on the example of solving Kepler problem and compare the results. The sensitivity report obtained by using MS Excel, according to which the Lagrange multiplier coincides with the results given above. Further, we demonstrate the solution of the above nonlinear programming optimization problems by classical methods of finding the extrema of functions of one Kepler problem and many variable Steiner problem using the necessary and sufficient conditions for the function extremum. Finally, we present a fragment of the Kepler problem solution by using a genetic algorithm. The results are acceptable in comparison with the above. Conclusions. Such methodological aspects of organizing student individual work in the process of teaching mathematical programming with the computer support contribute to the development of their creative abilities as well as mathematical and IT skills that they use in their professional activities. Thank you for attention.